Hello everybody. Today we're going to look at how do we perform operations with complex numbers, mostly just multiplying and dividing. We're also going to look at how we graph these on the complex plane. Alright, so just to remind us, a standard form of a complex number is a mix of real and imaginary, a plus bi. And then we also need to remember what this I is. Remember that I is the square root of -1. And because of that, I squared would just be -1. That's important to remember here in a second. Just for a quick example of that, 3i squared would be equal to what? -3. All right, so let's jump into how we multiply complex numbers. All right, basically all the same rules apply as just normal multiplication. You just have to remember that whenever you have an I squared, that's equal to -1. So here with 4i times -6 plus I, we're going to distribute the 4i to each term. That would be -24i plus 4i squared. Anytime that you see an I squared, just go ahead and cross it off and change the sign. And then now I want to write this in standard form, so I'm going to put the real number in the front, -4 minus 24i. If we have a situation like this, we can just use the FOIL rule to distribute. So we have 9 times both of these terms, so that would be -36 plus 9 times 7 is 63i. And then we're going to distribute these two here. -2i times -4 is plus 8i minus 14i squared. Okay, so remember, anytime I see an I squared, I just mark off the I squared and change the sign because we're basically just multiplying by -1. And now I combine like terms. -36 plus 14. That'll give me -22, and then 63i plus 8i is 71i. Dividing complex numbers can be a little bit trickier. Let's start with something that's just purely imaginary. Let's take 3 over I, right? So here we have just an imaginary number in the denominator. It's not complex because it doesn't have a real number attached to it. So what's actually happening here? This is the same thing as 3 over the square root of -1. And we've learned that we cannot leave a root in our denominator. So anytime that we have just a pure imaginary number in the denominator, we're going to multiply by I over I. You see, and what this gives us is, in the numerator, I'd have 3i over I times I is I squared. Well, I squared is -1, and 3i divided by -1 is -3i. So now I've taken my square root out of the denominator. All right, before we move on, I wanted to point out how we rationalize the denominator if we have a binomial here in the denominator. Remember that you had to multiply by the conjugate. So if this is 3 plus square root of 2, we multiply by 3 minus the square root of 2 over 3 minus the square root of 2. And the reason that, that we're going to do that is because now we have a difference of squares here, and so our denominator will get rid of all these square roots, and you just have the first term squared, 3 squared is 9, minus the second term squared, square root of 2 squared is 2. We're going to use that same logic for complex numbers because, again, I is just a square root of a negative number. So let's look at this example. 7 plus 5i divided by 1 minus 4i. What am I going to have to multiply by? The conjugate of the denominator. That is 1 plus 4i over 1 plus 4i. All right, in the numerator, we're going to do the same type of multiplication that we saw earlier. We're just going to FOIL these things. 7 times 1 is 7. 7 times 4i is 28i. And now 5i times 1 is 5i. And 5i times 4i is plus 20i squared. So that's actually just a minus 20. In the denominator, the first term squared minus the second term squared. 1 squared is 1, minus the second term squared. 4i times 4i is 16i squared. And now notice I squared, that's negative 1, so that changes the sign here. And no longer do I have an I in the denominator. So in the numerator, let's combine like terms. 7 minus 20 is negative 13. 28i plus 5i is 33i. All divided by 1 plus 16 is 17. All right, so here are two problems that you can try on your own, and then check your work to see if you got it right. So go ahead and pause the video. All right, so now you can take a second to check your work. So you can pause the video here as well. All right, the last thing that we're going to do today is plot complex numbers on the complex plane. That's what this thing is over here. It's whenever this axis is my real axis and this is my imaginary. On an actual graph, this is actually turned, and it's as if it's coming out of the screen. Okay, but we're not going to worry about that kind of stuff right now. So let's go through and plot these. 2 plus 2i. I'm just going to, 2 is my real, 2i is my imaginary. So I'm going to go positive 2 in the real, positive 2i in the imaginary. That would take me positive 2 to here. This point is 2 plus 2i. All right, for the next one, for I, there are 0 real parts. So I'm going to stay at 0 on the real axis and just go up 4i in the imaginary. So this is the point 4i. And the last one, we have negative 5 minus 6i. So I can just go back 5 in the real, down 6 in the imaginary, and I can plot negative 5 minus 6i. So basically, whenever you're plotting, just remember this axis is real, this axis is imaginary. All right, and that today we've covered how to multiply and divide complex numbers. We reminded ourselves that I squared is equal to negative 1, and we also saw how to plot complex numbers. Goodbye.